This video will explain how to calibrate the compound scope's ocular micrometer and demonstrate how to use it in measuring specimens that you are studying. Find the ocular micrometer on your scope by looking through the right ocular. The ocular micrometer is divided into 100 units, but we don't know what those units equal. So we must use a ruler of known size to compare or calibrate the unknown ocular micrometer. We do this type of measurement all the time. For instance, let's say we wanted to measure the height of this wall, and we only had this small ruler and no ladder. We know the size of this 12-inch ruler. We can use that known scale to measure the size of the bricks of the unknown scale and figure out the size of the wall. So now we can use the size of the bricks to measure other objects. The known scale for the microscope is a very small stage micrometer. Using the proper focusing techniques, place the stage micrometer on the mechanical stage underneath the 4x objective. You should see two separate scales, the ocular micrometer as well as the small 1mm ruler of the stage micrometer. Now line up the zeros of both the stage and ocular micrometers. How many units on the ocular micrometer does 1mm equal? As you can see, the 1mm on your stage micrometer is equivalent to 40 ocular units. So at the 4x objective, 1mm equals 40 ocular units. So the width of one ocular micrometer interval is 1/40th of a millimeter, or 0.025 millimeters. Now we'll do the calibrations at the 10x objective. Once again, you'll see two separate scales. The size of the ocular micrometer has stayed the same, but the stage micrometer is now at a higher magnification and looks bigger. Line up your zeros. At the 10x objective, how many units on the ocular micrometer does 1mm equal? 1mm is equivalent to 100 ocular units. Repeat these calibration procedures at the 40x and oil immersion 100x objective lenses. At these higher magnifications, you won't see the entire 1mm stage micrometer, and will have to calculate with less than 1mm. When you begin looking at the cells through the 4x objective, things are going to look very small. Make sure to use your microscope focusing skills to bring them into view. At this magnification, the field will be covered by thousands of tiny red blood cells. Try to find one that is isolated and do your best to measure it. It will probably be less than 1/3 of the ocular micrometer interval. To see it in more detail, move up to the 10x objective. Here you'll begin to see the larger red blood cells that look like donuts, the oval darker stained yeast cells, and the string-like bacteria. Find another red blood cell to measure, which will be about 1 ocular micrometer interval. At the 10x objective, we calibrated that each micrometer interval was 0.01 millimeters. Continue measuring the cells through higher magnification. Be as precise as you can and don't be afraid to move the slide around to line up cells on the micrometer. Use these procedures for the yeast and bacteria cells also located on your slide. Make sure to note the calibrations for your microscope, as you'll use them when observing other specimens later in the course.